All right, well, let's see if we can apply that then. So I'm going to look at each part separately. So as you know, it's what 1 over, tell me again, the square root of
1 plus ax
1 plus ax.
minus the square root of
Well, so I'm going to do just this bit first. So this one then needs to be rewritten as 1 plus ax to the negative half. So to do that expansion, we know the formula is 1 plus alpha x plus alpha times minus 1 x squared over 2. Okay, and we don't need to go any further, do we? Right. So let's apply that. So I'm going to do negative a half ax plus negative.
to negative 3x a squared x squared all over 2.
Okay. All right. Let's simplify that. So we've got 1 minus ax over 2 plus, so it's still going to be plus 3 over 8. Okay, so that's it for that bit. All right. Then we've got 1, the square root of 1 minus x, which is then 1 minus x to the power of a half. Okay, which becomes 1 plus half x negative x. Yeah. Plus a half times negative a half times negative x squared all over 2. Okay, which becomes 1 plus, so no, 1 minus x over 2 minus
x squared over 8.
squared over 8. Okay, so let's combine those two things then. So we've got that, and I'm going to subtract. So 1 plus x over 2
Yeah.
and plus x squared over 8. Yeah, which then if I mean, I'm overdoing it here, but then it's 1 minus 1 minus ax over 2 plus x over 2 plus 3a squared x squared over 8 plus x squared over 8. Yeah? Which becomes 1 minus a x over 2. Happy with that. Plus 3a plus 1
Squared.
squared over 8. Okay, so we now have that expansion up to x squared. Now we are told that that is equal to something. We are told that that is equal to 4bx plus bx squared. So I'm going to write 4bx plus bx squared. Okay. So therefore, I can now write that 1 minus a over 2 is equal to 4b. And I can write that 3a squared plus 1 over 8 is equal to b. Did you get that far?
So around mistaken. Subtract. things.
Okay, well, would you carry on from that point?
So first thing you do is isolate beer. In this case, it's isolated. So you can substitute 3a squared plus 1 over 8 for
So 1 minus a over 2 equals 4 times
3a squared
3a squared plus 1, 8.
So you can get 1 minus a equals 3a squared plus 1. And so over 2, we can multiply it by 2.
Yep.
Um, 3a squared plus a. Yeah. And then factor a. Get a 3a plus 1. So then we can get a can equal 0 or 1/3. Or negative 1/3.
Are you going to leave that as your answer for A?
Oh yeah. Okay, so a is negative 1/3.
Now, I will tell you, because I've seen the mark scheme, that if you write 0, you lose your answer marks for A. Because it's not a valid,
Yeah.
right, and you lose them. Alright. And now?
And now we took negative 1/3 for a to b.
So we've got B, either one.
1 minus.
So
Balance. Yeah, balance. 1 minus negative 1/3. So
1 minus plus 1/3 over 2 equals 4B. Divide by 4, so 1 plus 1/3. So divide by 4 both sides. Yeah. So we've got 4/3 times. Sorry.
Over 3.
33 over
32 over 3.
32 over 3. No. It's not. So what's gone wrong? The answer? B should be a 1/6,
6.
which is 1/6. All right. So at what point do you think you got lost, and why? State the restriction. Now you said x must be less than what? And what's your reasoning for that? And I agree with your reasoning, but there is something missing.
There is no real solutions for x is greater than 1.
Okay.
But there is this.
Okay. Now I guess for me, there's a word in here that maybe you guys missed when you were doing this, which is state the restriction which must be placed on x for this expansion to be valid. So you're not finding solutions, you're expanding. What's the difference? Why is this that? Why are there no solution? Why are we not even looking for solutions? There's no equal, so we're not looking for solutions of any kind. What is an expansion? Changing form. What should both of those forms do? The same thing, and then what are they used for? So basically, this is an expression, and what do we do with expressions? Put a value in, yeah? And what comes out? A number, yeah? So when we expand this, the expansion is just another form. And if I put the same number of x in, it should give me a number, the same number, right? So just to simplify that a bit, let's take a very basic 3 plus x squared. What's the expansion?
Square root of 6x. Yeah.
If x is 4, this becomes 49. This becomes
16.
49. Yeah, yeah, we know that's right because it makes sense. So therefore, this is just like you said, a different form. Now, I believe in this sense you've missed a fundamental thing about expanding non-integer values and non-positive values of the exponent. What did we miss? Well, I think we missed the nature of the formula. What is that? What's the nature of that formula that's different to when it's a whole integer value? Positive. Yeah, this is an infinite, or it doesn't converge. What do you know about an infinite geometric series? How can I evaluate an infinite, or can I always evaluate an infinite geometric series?
You can't if the ratio of terms, you can only do it if the ratio of terms between 0. Yeah, if it can't subtract one, so okay, because it would diverge, so it has to be the ratio is less than 1. And the negative 1.
And why is that?
Because otherwise the terms get larger and therefore.
Yeah, so you remember, if we talk about if it's greater than 1, what happens? Well, the points go, right? If I try and add those together, it's just going to get an infinite, and I can't add up an infinite number of bigger numbers. What happens if r is negative 1? Well, it just goes, instead of doing that, it goes, yeah? And again, I can't do that. So I rely on, if I'm doing a geometric, what's it got to be like? It's got to be like this, yeah?
Yeah.
So we converge at a point. Now, is this formula a formula for an infinite geometric series?
Yes.
What's the ratio?
X.
Yeah? Because these will just be constant values, right?
Yeah.
X is what changes, that's what changes the behavior of it. So X is the ratio for this. Therefore, if, remember again, an expansion should give me a number.
Yeah.
An infinite geometric series only gives me a number if
The
it converges. So if So if the ratio only becomes a number if it converges, an expansion will only give me a valid result if it converges. Therefore, x must be between 1 and -1. Now, there is a slight addition to this because we've got 1 over root 1, was it plus or minus? I can't remember. Plus ax minus the root of 1 minus x. Now, this one is just x must be between 1 and -1. This one, however,
So one B.
no, it's not that. It's this
Oh,
time
the
ax must be between 1 and -1. Yeah?
Yeah.
So we know that a is a third, negative a third. So this will be negative x over 3. All right. Now, what does that basically make it? Okay, so x must be between 3 at -3. So we've actually got 2 different restrictions, but
It's
and which one's that? Yeah, so this is the important one because this one sort of gives values that I'm not allowed in that
Yeah.
one. So therefore, this one's not important because it's overridden by this one. So you will see in the mark scheme, we write that because the two things mean the same thing. Does that make sense?
Yeah.
So I do think that we missed that important. So hopefully Liam's listening on the video when he watches it. We missed that important factor of the expansion of non-integer positive values for an expansion. It's an infinite series, therefore that rule applies. All right, makes sense.